Hi there, Mathketeers. I'm Mr. Lineberger, and today I'm imagining my garden. As usual, I'm also thinking about math. When I look at my garden, all the plants in nice, neat rows, it reminds me that sometimes it's a good thing to be able to visualize a math concept. That means that sometimes I need to see a math idea as a picture to really help me understand it. When I think about all the goodies I'm going to pick for my garden, it helps me start to visualize an important math concept: division. Today, we're going to look at some ways to represent division. Now, it's important to know that what we're doing today is not a very efficient way to solve division problems. We'll get to that later. Today's goal is just to be able to have some strategies for representing a division problem so we can see what division really looks like. I love growing hot peppers. I like to blend them together to make some tasty hot sauces. When I picked peppers this morning, I got this basket with 25 peppers in it. I know that I need 5 peppers to make a bottle of hot sauce. So my division problem is an easy one: 25 divided by 5. I'll bet you could do that in your head. But let's create a visual representation of it just so we can see what division really looks like. One way I can do this is with a picture. I'll draw 5 empty bottles that will soon be filled with tasty hot sauce. 1, 2, 3, 4, 5. There are my 5 bottles. And here's my basket of peppers over here. You know how when you're dealing cards or counting out pieces of candy to share, you give one to each person until everyone has one, then you start back over at the beginning? That's what I'll do with my peppers. Here's 1 in the first bottle. Number 2 goes in the second bottle. Number 3, that goes in the third bottle. Number 4 in the fourth bottle. And number 5 in the last bottle. There's more peppers still in the basket, so I'll keep going until they're all gone. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, done. All the peppers are now in bottles. I can see that I have 5 peppers in each bottle. So the answer to the problem, 25 divided by 5, equals 5. But remember, the point here is to be able to represent division, not necessarily solve problems this way. It's too slow. I could also represent this division problem with a number line. Number line appear! We'll start at the number 25, since that's my total, and in this case, it's the dividend. Let's label the number line 1 through 25 like so. Starting at 25, I'm going to count backwards by 5s, and I know that each time I do, I'll have enough peppers for a jar of hot sauce. Here's the first step, hopping backwards by 1, 2, 3, 4, 5. That puts me at 20 peppers left, and 1 bottle of hot sauce appears like so. If only it were that easy. Jumping backwards 5 more, and I've got a second bottle of sauce. We'll do the last jumps quickly. Jump, jump, jump. A total of 5 skips to count backwards by 5 from 25. And we have 5 bottles of hot sauce. Let's do one more representation using base 10 blocks. I've got 25 blocks here, and I want to put them into 5 groups. I'll just drop the blocks in the groups. Since we have a small number of blocks, I'll use individual ones. Later, we'll use some bigger numbers, but for now, just singles. And there you have it. 5 groups of 5 blocks each. 25 divided by 5 represented with base 10 blocks. I might even think about this in terms of a rectangle. I know this rectangle has an area of 25, so that's a length of 5 and a height of 5. I could color in the groups to represent this division. Here's one group of 5, let's color that blue. Another group, that could be green. A third group will be brown. A fourth group can be orange. And the last group can be red. Voila! 25 divided by 5 represented in a colorful way. In addition to making hot sauce, I'm also growing tomatoes, onions, and some super hot peppers to make spicy salsa. These hot ones are so hot, you only need 3 for a big jar of salsa. Yesterday, I picked 51 peppers. So, how many jars of spicy salsa can I make? Our division problem is 51 divided by 3. Let's create some visual representations of that. We can start with pictures, like we did last time. Here's my 51 super hot peppers. I'm dividing this set of peppers into groups of 3. So let's just circle groups of 3 and count them as we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and here's the last group, 17. I've circled 17 groups of 3 with none left over. The answer is 17. And I've represented that with a picture showing 17 groups of 3. We could do the same thing with a number line. Here's our number line. It starts at 0 and goes all the way out to 51. We're skip counting by 3 going backwards. That's hard for me to do in my head, but when I have a number line in front of me, it's not tricky. Our first skip goes to 48, then 45, then 42. Remember, each of these skips is a group of 3 peppers that I'll need to make a jar of salsa. So keep skipping. 39, 36, 33, 30, 27, 24, 21, 18, 15, 12, 9, 6, 3, 0, 17 skips, 17 jars of salsa. We have represented the division problem using a number line. Let's tackle this same problem with base 10 blocks. I've got 5 groups of 10 and a single block. That makes 51. I'm going to divide them into 3 groups. I can give a stick of 10 to each group. 1, 2, 3. But now I need to break up my remaining blocks into singles. I'll distribute these now. And done. We already know, because we've worked this problem a few times before, that each group will have 17 blocks in it. And there you have it, 51 divided by 3, represented by base 10 blocks. We could also use the area model strategy to help us represent the problem. I'm going to draw a rectangle with one side being 3, and the total area we know is 51. The first number I think of that would be safe to multiply by 3 is 10. 3 times 10 is 30. That leaves us with 21 left. I know that 3 times 7 is 21. That's one of my multiplication facts. So the length of the side is 17. I'll draw this out like a grid. The rectangle is 3 blocks high by 17 blocks wide. When I look at this, I see 17 groups of 3. I'll color them in like this. It's one thing to solve division problems, but it's also just as important to be able to understand what division really looks like. Today we represented division problems by creating pictures, drawing on number lines, coloring in groups in an area model, and by making piles of base 10 blocks. That's 4 ways to represent each problem.